Hey guys, welcome to Friday's lesson. So first up, we'll just look ahead towards the next 19 days. Why did I choose 19? Well, there's 3 days left this week. You can tell I'm counting out the days to the isolation period ends. There's then 14 days of holidays, but we haven't got that much to do, so why not do maths? And then 2 days following that to Easter. And I think we can get ahead of the game here because if we're doing a little bit of maths every single day, um, then we'll actually be ahead of kind of where we were at before this whole thing happened. So term 2 starts straight after Easter. Speaking of Easter, did you hear that Donald Trump wants to open America before Easter? It's crazy. Anyway, so we're going to do some trig problems. I told you in the last video we'll do a variety of them, some extension ones in there. We're going to do one per day. There's various reasons for that. At my end, it's quite difficult to get these problems out to you. I don't have a good photocopier, but I can type, and the typing of trig takes ages, so we're going to spread it out one per day. And I thought, why not do 19 problems, because it's a prime number, keep us in our prime, try them first. Yeah, I'm going a bit crazy. Right, so problem 1. This is where I will show you the problem, and you pause the video and give it a crack yourself. Alrighty, so we need to prove that this here equals that, and I've decided I'll start on the left-hand side. And the reason for that is it's easier to expand out these tan things than it is to factor. We can see the right-hand side's got a common factor in the numerator, and the bottom is a difference of 2 squares. So sure, we could do some algebraic trickery on that. At the left-hand side, we know that there's a formula that can expand out compound angles, so it makes more sense to start there with the trig identity. So, have you actually tried the problem? Good. I see you all nodding. It's just like class when you're all quiet. Right, so left-hand side. The 3 terms there, when we expand out these guys here, we get that using the compound angle formula. Tan 60 is a nice number, √3, if you didn't know that. You could type tan 60 into your calculator, being in degrees, and when you do that, you'll square it and see it's 3. Or you just need to know that 60 degrees is a special angle. If you're not sure about special angles, have a look on Google. But 60 degrees is part of an equilateral triangle. If you split the equilateral triangle into half, you have a 60, 90, 30. And those angles there generate nice results with the trig expressions. 120 is related to 60. 60 plus 120 equals 180. So you're going to get some nice results there. See that tan 60 is √3 and tan 120 is negative √3. That is based on some of the work we did earlier in the topic. They're supplementary or complementary, I can never remember, but they add to 180, so you're going to get a relationship between those angles. All right, expanding those out and changing the 60s and 120s to √3s. Now we put these fractions together here. Makes sense to do that before we include this tan alpha because of the symmetry in the problem. Add the fractions together, denominator becomes a nice thing, and hey, it's in the right direction. It's exactly where we were heading. The numerator cancels down, simplifies down a lot to that. Now we put the tan alpha with it and factor out the common factor of 3. Now the trickiest part, I guess, is noticing that this here is actually tan of 3 alpha, and the way you can do that is by how would you do that? You'd use the compound angle formula with tan of alpha plus 2 alpha and expand it, and then you'll have to expand the tan 2 alpha again. So that's last step's not convincing at all, but it's a result I'd seen before. You need to convince yourself about that. Right, and following this is an extension problem. I just thought about it as I was putting this presentation together. It's a similar type question. The maths involved is quite similar, but you could have a go at that. And if you need any help or want an answer to this question, feel free to email me.